All right, this is section 5.3, solving trigonometric equations. Today we're finally going to be able to say x equals, insert answer here. So we'll start off with this one. In order to solve an equation, we want to get all of the trig functions together. So I'm going to add the sine of x to the other side. Sine of x plus sine of x makes 2 sine of x equals 0. And now I want to get the sine of x alone. So I'm going to subtract that square root of 2. And then I need to divide out this 2. So my answer is the sine of x equals negative square root 2 over 2. But now I need to know what x is. So I look at my unit circle and I say, okay, where's the sine negative square root 2 over 2? One answer is 5 pi over 4, and another is 7 pi over 4. But I want all the possible solutions. So think about how often sine repeats. Well, the period is 2 pi, so I put plus 2n pi, because it could be 2 pi, 4 pi, 6 pi, on and on. Same thing over here. You may say, well, Ms. Dupree, last unit we undid sine and our answer could only be between negative pi over 2 and positive pi over 2. 7 pi over 4 definitely isn't in there. It would be negative pi over 4. But negative pi over 4 plus 2 pi is 7 pi over 4. And also we want to talk about anything on the unit circle that would work, so we have to give both answers. The problem doesn't say arc sine, so we don't have to worry about the quadrants that it's in. So when we're solving, find any angles that satisfy the trig function on the unit circle. They don't say arc sine, arc cosine, or arc tangent, so you don't need to worry about the domains. Then you add 2n pi to all solutions, and you remove redundant solutions, so ones that are like pi over 2 plus n pi, and then pi plus n pi. I can shorten that into just one answer. So that's the one we just did, so I don't know why I have it twice. Sorry for that. Let's solve this one. So I start by getting tangent alone. Add 1 to both sides. Divide by 3. And then I undo the square with a square root. That gets me tangent of x equals plus or minus, square root of 1 is 1, square root of 3. Well, we don't usually leave it like that. We would probably change it into square root 3 over 3. But either way is okay, because all I care about is what angle has that tangent. So that would be pi over 6, 5 pi over 6, because I can also have negative, 7 pi over 6, and 11 pi over 6. Our rules said add a 2n pi to all of these. Now this answer is absolutely fine. It's correct. It'll work. But what happens if I take pi over 6 and add pi? I get 7 pi over 6. If I take 5 pi over 6 and I add pi, I get 11 pi over 6. Really, with tangent, instead of doing plus 2n pi, I can actually just go plus n pi and only worry about the first 2 solutions I get. I wouldn't take off points if you gave me all 4, but if you have the 2n pi's, you need all 4. All right, next problem, very, very similar. Get the sine alone. So I add 3. I have 4 sine squared of x equals 3. I'll divide by 4. Sine squared of x equals 3/4. To undo a square, I square root. So the sine of x equals plus or minus square root of 3 over the square root of 4 is 2. So I'll look for anywhere that the sine of x is square root 3 over 2. I look at my unit circle. Sine is square root of 3 over 2 at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Oops. Anytime you have a plus or minus that you're solving with, chances are your domain will be less than, your repeats will be more often than every 2n pi. Because pi over 3 to 4 pi over 3 is pi apart, and 2 pi over 3 to 5 pi over 3 is pi apart, I'll make my answer just pi over 3 plus n pi, and 2 pi over 3 plus n pi. If I put all 4 answers plus 2n pi, that'd be fine as well. So new first step, convert to one trig function if at all possible, or at least factor one trig function out as a GCF. But be careful. Keep in mind values that would make the original equation undefined. We could end up with some extraneous solutions here. I'll show you what I'm talking about. This problem, well, we want to start off by getting all my trig functions on one side, so I'll subtract 2 cotangent of x. So I have cotangent of x times cosine squared of x minus 2 cotangent of x equals 0. Now I could change cotangent into cosine over sine, but then I'm going to have sines that I'm going to have to work with. Also, I'm still stuck with 2 trig functions. I do notice, though, that the left side I could factor out a cotangent. If I do that, I'm left with cosine squared of x minus 2. Okay, well that actually is very helpful, because when I factor something, I can set both factors equal to 0. So cotangent equals 0, and cosine squared of x minus 2 equals 0. Cotangent is already alone, so I'm going to work on this other one. I'll add 2. Cosine squared of x equals 2. I'll square root. So the cosine of x equals positive or negative square root of 2. Now I go to my handy-dandy unit circle. Where is cotangent of x equal to 0? Well, remember, cotangent is cosine over sine. So I want where the cosine is 0, which is pi over 2 and 3 pi over 2. And the period is at pi, so I just go pi over 2 plus n pi. Now I look for where the cosine of x equals positive or negative square root of 2. Well, you may not realize this, but the square root of 2 is more than 1, which means that doesn't give me any solutions, because cosine can never give me an answer more than 1. So my answers are pi over 2 plus n pi. I double check that nothing would make me divide by a 0. Cotangent is defined at both of those. Cosine is defined at that. We're good. All right. Next problem. Can I just divide both sides by sine of x? No. You lose a solution if you do it that way. So we really want to subtract 2 sine of x, get it equal to 0. This is why we always say get it equal to 0. We take out the GCF. GCF is sine of x. And then we set both pieces equal to 0. So sine of x equals 0, and sine of x minus 2 equals 0. Get that sign alone, I'll add 2 over. Sine of x equals 2. All right, where does sine of x equal 0? Well, that is at 0, pi, 2 pi, 3 pi, 4 pi, every whole number pi. So I'm actually just going to call it n pi. Where does sine of x equal 2? Nowhere. Not possible. So here this goes 0, this goes pi, on and on and on, so n pi. The reason, sorry, let's go back to this little. If we had just divided both sides by sine, we would have had sine of x equals 2. Oh, we would have said no solution. That wasn't our answer. Our answer was n pi. Now a slightly different type of problem. 2 sine squared of x minus sine of x minus 1 equals 0 on the interval 0 to 2 pi. We will not need that plus 2n pi on the end anymore because it told us just on this interval. So I just give the numbers in there, and then I'm good. So we are going to factor this one. 2 sine of x and sine of x. The only way to get a 1 is a 1 and a 1. To make it minus in the middle, we'll put the minus there and the plus there. Then we set both factors equal to 0. All right, let's get sine alone. I'll subtract 1 over here. I'll divide by 2. So sine of x equals negative 1/2. I look at my unit circle. Where is sine negative 1/2? That's 7 pi over 6 and 11 pi over 6. Then I'll solve this other piece. Add 1 to both sides. Sine of x equals 1. Well, between 0 and 2 pi, where is sine 1? Pi over 2. So I have 3 answers for my x value. All right, same thing. We're going to solve on the interval 0 to 2 pi. And I'm going to factor again. 2 sine of x and sine of x. To get a 1, I can only use 1 and 1. To make it a minus 3 in the middle, they'll both be minuses. Very similar to the last problem. Set each of these equal to 0. Add the 1 this time here. Divide by 2. Where is the sine of x 1/2? That's pi over 6 and 5 pi over 6. Add the 1 here. Where is the sine of x 1? That is pi over 2. So those are my answers. All right, this one, it's an issue because we have different trig functions. So I need to use my properties to rewrite it. Where does sine squared of x equal 1 minus cosine squared of x? Well, what's 1 minus cosine squared of x? That's sine squared of x. This is one of those funny problems where something equals itself. So the answer is actually all real numbers. If it's an identity like that, it's all real numbers. Anything would work. Now let's try this. I have secants and tangents. Uh-oh, I need to choose one. I personally would rather work with tangents because those are easier to find on my unit circles usually. So I'm going to change secant squared into 1 plus tangent squared of x. Keep the rest the same. Let's distribute that 3. 3 plus 3 tangent squared of x minus 2 tangent squared of x minus 4. Combine my like terms, I get tangent squared of x minus 1. All right, add that 1 over. I could factor this also, but I'd rather go this way. And then undo the square with a square root. So I get the tangent of x is positive or negative 1. So I'm looking for all solutions. So x equals pi over 4. 3 pi over 4 gives me a tangent of negative 1. 5 pi over 4. 7 pi over 4. On and on and on. Now this one I notice I can write even shorter than pi over 4 plus n pi and 3 pi over 4 plus n pi. It's going up by pi over 2 each time. So I can actually say x equals pi over 4 plus 2 n pi over 2. There we go. That's where the 2 goes. That is a shorter version of our answer. All right, cosine of x plus 1 equals sine of x on the interval 0 to 2 pi. that's not a property or anything along those lines. So what on earth am I trying to do with this? The only way to make it a property is to square both sides. And that is a special trick. So when I square the left, I get cosine squared plus 2 cosine of x plus 1. And the right gives me sine squared of x. Now I can rewrite it in just cosines. So I will change sine squared to 1 minus cosine squared. And then I'll get my like terms on the left. Add cosine squared. Subtract that 1. I get 2 cosine squared of x plus 2 cosine of x equals 0. Now let's factor out our GCF. 2 cosine of x times cosine of x plus 1. Set both pieces equal to 0. 2 cosine of x equals 0. And cosine of x plus 1 equals 0. Divide this first one by 2. Cosine of x equals 0. Subtract 1 over here. Cosine of x equals negative 1. All right, on the interval 0 to 2 pi, so where is cosine 0? At pi over 2 and 3 pi over 2. And where's cosine of x? Negative 1. That's at pi. There are our answers. Oops, skipped one. There we go. Another one very, very similar to that. We're going to square both sides again. All right, I get sine squared of x plus 2 sine of x plus 1 equals cosine squared of x. I'm going to substitute cosine squared with 1 minus sine squared. And then I'll get everything on the left-hand side. So I'll subtract that 1, and I will add sine squared, making 2 sine squared of x plus 2 sine of x equals 0. And just like the last problem, factor out 2 sine of x, leaving me sine of x plus 1 equals 0. Set each factor equal to 0. Divide this first one by 2. Subtract 1 for the second one. So I want on the interval 0 to 2 pi where sine of x equals 0. Notice my interval, 0 is included, 2 pi is not. So sine is 0 at 0, pi, and 2 pi, but 2 pi is not included in my solution set. Where's the sine? Negative 1, that is 3 pi over 2. There's my solution. All right, now we're going to switch it up a little. Now I have a number inside the trig function. This does not affect the first steps. We still get the trig function alone. Add the 1. Divide by 2. And now what angle has a cosine of 1/2? Well, pi over 3 and 5 pi over 3. Remember, those are plus 2n pi, unless I find a better way to write it. But now it's not x equals that. It's 3t equals each of those. And I want to know what t is, so I need to divide by 3. That gives me pi over 9 plus 2n pi over 3. And divide the second one by 3 also. I get 5 pi over 9 plus 2n pi over 3. So you don't deal with that number in with the angle until the very last step. So very similar here. We start by isolating our trig function. So I'll add the square root of 3. I get 2 times the sine of 2t equals square root of 3. I divide by 2. The sine of 2t equals square root 3 over 2. All right, on the unit circle, the sine is square root 3 over 2 at pi over 3 plus 2n pi, and at 2 pi over 3 plus 2n pi. Well, now I need to get that 2 out of there because the angle was 2t in each of these, so I divide by 2. I get t equals pi over 6 plus n pi, and divide the second answer by 2 as well. I get t equals pi over 3 plus n pi. Notice that the n pi portion is also divided by that number. Now we're going to have tangent of x over 2 involved. Same thing as before, subtract that 3. And then divide by 3. I get the tangent of x over 2 equals negative 1. So I think, where is tangent negative 1?
Good afternoon, this is Mr. Lipsky.
All right. Sorry, 3 pi over 4. Tangent's also negative 1 at 7 pi over 4. And tangent, remember the period is just n pi. X over 2 equals each of those. Now I can take the second one out because it is redundant. I added just another pi. So then, instead of dividing by 2 this time, I'm going to multiply everything by 2. So I get x equals 3 pi over 2 plus 2n pi. And there's my answer. All right, this one's very similar, except that we have 2 tangent of x over 2 minus 2. So I add the 2 over. I divide by 2. Where is tangent equal to 1? Well, that is at pi over 4 plus n pi. And 5 pi over 4, which is n pi away. So we're okay here. X over 2 equals pi over 4 plus n pi. Multiply both sides by 2. X equals pi over 2 plus 2n pi. All right, now a trig problem. We have 2 different trig functions. I'm going to change secant squared into tangents. Secant squared is equal to 1 plus tangent squared minus 2 tangent of x equals 4. I'm going to subtract that 4 over. Tangent squared of x minus 2 tangent of x minus 3 equals 0. Now I can factor. I get tangent and tangent minus 3 plus 1. All right, we set each factor equal to 0. Add 3 in this side. Subtract 1 over here. Well, I do not know where the tangent of x equals 3. Not something I know. But I do know that x would then equal the arctangent of 3. And it repeats every n pi. That's as good as I can get without a calculator. If the tangent of x is negative 1, though, that is at 3 pi over 4 plus n pi. All right, similar type of problem, but this one's all in terms of tangents, so I'm going to start with factoring. Now I need to decide, do I want to use 4 tangent and 1 tangent, or 2 tangent and 2 tangent? I actually think I want to go 4 and 1.
This is a lockdown.
All right, for tangent of x and tangent of x, My 6 I'm going to break into 2 and 3. I'm going to put the 2 there and the 3 there. So that makes 8 minus 3 to give me 5. So positive 2, negative 3. All right, now I set each factor equal to 0. And solve for tangent of x. I'll divide by 4. Tangent of x equals 3/4. Now, I don't know where the tangent of x equals 3/4, so I'm just going to have to go with arctangent of 3/4 plus n pi. That's what I have to do here. This one, we subtract 2. Tangent of x equals negative 2. And again, I don't know that value, so x would also equal arctangent of negative 2 plus n pi. All right, this one gives me an interval. So again, I would try to factor. But uh-oh, this problem will not factor. Nothing multiplies to 2 and adds to 6. I can actually do quadratic formula if I need to. I can say, instead of x is equal to, sine of x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I simplify that. I have negative 6 plus or minus the square root of 36 plus 8 all over 2, which is negative 6 plus or minus the square root of 44 over 2, which means that sine of x is equal to negative 6 plus or minus 2 square root 11 over 2. Divide everything by 2, I get negative 6 plus negative 3 plus or minus the square root of 11. Now both of these answers may not work. If I type in negative 3 plus the square root of 11, I get 0.31 blah blah blah. If I type negative 3 minus the square root of 11, I get negative 6 point something. Negative 3 minus the square root of 11 does not work. So I really just have sine of x equals negative 3 plus the square root of 11. But I don't know where that is on the interval 2 pi, so I have to use arcsine. Arcsine of negative 3 plus the square root of 11. I get 0.322-ish. Thinking about the unit circle, right? That's about here. This angle has the same sign. So how far away from pi is it? Well, it's pi minus whatever that angle is. So I'll take pi minus 0.322. So my other possibility is 2.820. All right. Same type of thing. I don't have a way to factor this problem. So I'm going to go sine of x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a, which makes negative 2 plus or minus the square root of 8 over 2. So I'd rewrite that as negative 2 plus or minus 2 square root 2 over 2. So the sine of x equals negative 1 plus or minus the square root of 2. Negative 1 minus the square root of 2 absolutely will not work out. So the sine of x equals negative 1 plus the square root of 2 only. Inverse sine of negative 1 plus the square root of 2. X is about 0.427. And again, we're going to do the same thing as before. I want to know this angle here. Well, it's the same, so that much shy of pi. I'll take pi minus 0.427. So my other possibility is 2.715. Those are in radians. All right, and now for a word problem, everybody's favorite. So the surface area, S, in square inches of a honeycomb cell is given by this crazy looking function. where h is 2.4 inches, s is 0.75 inches, and theta is the angle shown in the figure. What value of theta gives the minimum surface area? So step 1 for this would be plug in the numbers it gave you. It gave me h, it gave me s. So capital S is equal to 6 times 2.4 times 0.75 plus 1.5 times 0.75 squared times the square root of 3 minus cosine of theta over sine of theta. All right, let's simplify that a little bit. 6 times 2.4 times 0.75. That's 10.8. 1.5 times 0.75 squared, 0.84375. Square root of 3 minus cosine over sine. All right, now I need to find the minimum. I don't really have a good way to mathematically find the minimum, but I can use my graphing calculator. Notice that it says the angle is between 0 and 90 degrees, so I need to switch my degrees, or my calculator, to degrees. Then I'm going to type in my function. 10.8 plus 0.84375 parentheses square root of 3 minus cosine of x divided by sine of x. All right, a few things to notice about my function here. I started a set of parentheses for the numerator. I've got a set of parentheses in the cosine. Then my numerator closes. My sine got an x in parentheses, and then my whole fraction is in parentheses as well. Lots of stuff going on. Then I want to change my window because I know that I want to get up to my angle being 90, so let's go 100 just to be safe. I don't know what my y values are going to be. Okay, my y values are probably going a bit too high. Let's go 50. When I did that, I could see that it goes down and then slightly back up. So I do have a minimum in there. So second, calculate my minimum. All right, make sure I'm on the side of it that it starts getting bigger again. Watching my y values. Press enter to guess. Minimum x is 54.735612. Y is 11.99. So my answer for theta is 54.736 degrees. Calculator is very helpful. All right, you'll have a worksheet to practice this.